Hello everybody. Believe it or not, this is take 3 of this particular attempt to record the lecture. The first time I recorded the lecture, it was audio only, which is very exciting. And the second time I recorded the lecture, it was video only, which is also very exciting. So now I believe I have the audio and video working, so here goes. You should have this in your notes, the sample audio and video controls in HTML. And I just wanted to spend a little bit of time reviewing the attributes, and then I want to talk specifically about the file extension. So the controls attribute inside video and audio is going to allow some on-screen controls to play, pause, rewind, fast forward through the audio or video. The source is going to specify a source location for the audio or video file. If you don't specify any file directory information or URL, the system's going to assume that the file is located in the same directory as the HTML file that contains the HTML for the audio or video element tag. This option, the poster option in video, lets you put up a little thumbnail print instead of showing the first frame of the video. And if the browser is not able to play the video or audio for some reason, then not available will show up in the browser. Alright, so I'm going to talk now a little bit about this extension here and here, .mp4 and .mp3. These are called containers, and they're responsible for containing the codec encoding of the audio or video that you'd like to watch. So codec stands for coder and decoder. And there's a bunch of different algorithms that are used to encode and decode audio and video signals. And the algorithms are associated with specific names, and those names are stored as part of the information about the audio and video file that the container wraps around. So you can have a container that's an MP3 file, or an MP4 file, or a .mov file. I think .mov is actually a really good example of a container. The .mov file can have lots of different codecs inside of it with information about what specific codec was used for the audio or video signal that was encoded. So I want to spend a few moments talking about how codecs work. I'm not going to go into super duper detail because we could spend a bunch of weeks, a whole couple of weeks talking about how codecs work, but I do want to give you some idea of how they work. So imagine this sine wave that I'm showing you here is an analog signal, all right? So it's music traveling through sound via sound waves to a microphone. All right. So the way the signal gets encoded, the analog signal gets encoded into a digital signal, is that the microphone feeds to something that takes a sample and holds that sample in memory for a moment. Now, the rate at which those samples are taken is controlled by a clock. Okay, and that sample is then converted into converted from analog to digital converter, and out comes a digital encoding. All right, so I want to talk a little bit about, imagine this analog signal coming into the system. We take a sample of the analog signal, and then what do we do with it, or how do we go about how often should we take that sample? So I'm going to show you an example of a. Let me do this. Change. I know there's some super cool way I can change the pen settings. Here we go. Yeah, that's good. Give me a different color. All right. Okay. So imagine this line here is the y-axis. So this is the y-axis. Let me change that back to. Oops. Change this back to blue. Is that the blue I was using? There's the blue I was using. Okay. And here we have my analog signal coming in. All right. There's one cycle. Comes another cycle of the analog signal. Okay. I'll do one more here. Great. All right. Now, one really great way to convert this analog signal into a digital signal is to just sample the heck out of it. All right. So in a single cycle, if we take tons of samples of the signal, and each one of these dots represents a moment in time where we hold the amplitude of the signal. That's how we're going to represent the signals, by the amplitude at a moment in time. Boy, if you just connect the dots just within that one cycle, you're going to have a pretty accurate representation of the analog signal. All right. The problem with that is that it's going to use up or take up a lot of memory. All right. So an audio file, which could turn into a 3-minute audio file, could turn into a gigabyte worth of information, which that's a lot of information. So one of the problems that we encounter all the time in computer science and in computer engineering is that there's trade-offs. So get a really accurate representation of that analog signal, we got to take a ton of samples, and that makes for a very large digital representation, which isn't great. So what if, instead of taking lots and lots of samples, we took just a really small number of samples? In fact, by small, what I mean is, what if we took one sample every cycle of the signal, of the analog signal? All right, so here I am. I'm taking one sample every cycle of the analog signal. Well, that's not so great, because what's happening here, if I look at my digital representation, is I have a whole bunch of samples at, say, like the highest point, highest amplitude value in the signal during a cycle. And I don't actually even know, once I'm done, I don't really know that that's the highest point. All I know is I've got these dots, and I'm going to just connect the dots. So my representation of the analog signal doesn't look like a very accurate representation of the original signal. So sampling once per cycle, that frequency is not such a great strategy. All right, so what if I sampled maybe 1.5 times per cycle? All right, so I'm not sampling 1 time per cycle, I'm sampling 1.5 times per cycle. So here's a sample, and to make it 1.5, I'm not going to sample at the exact same spot up here. I'm going to be more like down here for my next sample, because I'm doing it a little bit more than one time per cycle. And then I'm going to sample again, and again, and again, and again. Now, that's, so it's almost a full cycle, but not quite. 1.5 times per cycle All right, so what does this look like if I delete the analog signal? Well, got something here. If I look at this and say, well, you know, maybe there's some kind of sine curve here. If I try to make the sine curve fit, I'm going to have something that looks like this. So it's not a real accurate representation of what I had originally. In fact, what I've basically done is stretched out the cycle of the analog signal. I have an inaccurate representation of the signal. Things are moving with a lower frequency. I have a lower frequency sine curve that I'm representing. So 1.5 times per cycle is not such a great idea either. So what if I sample 2 times per cycle? Okay, there's 1, 2. Now I start the next cycle. 1, 2, 1, 2. Hey, this is looking pretty good. Now, even if I don't know that what I have here is a sine curve, I mean, if it is a sine curve, that's really helpful. But if I don't know it's a sine curve, and I just connect the dots, I'm getting a more reasonable representation of the original signal than I had with just 1 sample per cycle and 1.5 samples per cycle. So that's good. And this actually has a name. This rate of sampling, sampling at 2 times the frequency of the analog signal, is called the Nyquist rate. So at a minimum, if you're trying to create a digital representation of an analog signal, you want to sample at 2 times the frequency of the analog signal. And if you can sample more than that, 3, 4, 5, 6, 7, that's great. But of course, the more you sample, the larger the file is that you're going to have. So you have to watch out for that. All right, so let's go back up here again. I just spent some time talking to you about how this encoding works. And that was because I had been talking to you about the file extensions on the audio and video files that we were looking at. Now what I'd like to do is I'd like to talk a little bit about general kinds of audio and video containers and codecs. So here's the container name, and here's the video codec for the container and the audio codec for the container. So common containers that you're going to find out there on the interwebs are the OGG container, that's .ogv, and that has Theora as the video codec and Vorbis as the audio codec. Something called WebM, which Google tried really hard to get everyone else to adopt, but it didn't work out. That uses the VP8 encoder and codec for video, and the Vorbis codec for audio. And MPEG-4, that uses the H.264 codec and the AAC codec for audio. And you're watching right now the QuickTime move format, and that uses a container, and that has lots of different audio and video codecs. All right, so that wraps up our discussion of audio and video formats. Just before we go, I just wanted to show you an example of a web page. Let me just bring shrink this down a little bit, that uses different types of audio and video. So different types of media. So I've got some image media. I've got examples here of image media in conjunction with text. So here you see bed appear down here. Bed bottom alignment is default. You can have the text appear in the middle of the image or the text at the top of the image. That's using style inside the HTML, which is something I told you is kind of a big no-no. We want to use CSS to do that. However, sometimes people do it, and I just wanted you to be aware of how you could go about doing that. So if you go to the course website and you click on the media page, by the way, good sound effects there, and you can take it. You can see how that's done. Here's an example of taking an image and really using it to make something look cool. So I said once upon a time there was an image floating on the left and an image floating on the right. So here's the image floating on the left. Here's the image floating on the right. And there's text between the two images. So that can look pretty cool. So for your project that's due this coming Monday, I'm okay with using a little bit of style in the HTML if you want. But after that, I'm going to say put all that stuff in CSS, in the CSS files. So here's a cool audio file. Ooh, very nice. And I've got 3 different examples of using video. So one is the MP4 file, and it looks very much like the example that you have in your notes. There's a little frog action there. And here's a video, a YouTube video of Frog and Toad, which I love Frog and Toad. They're awesome. And this is such a great little bit about using willpower, trying not to eat the cookies, which is very hard for me to do. I love cookies. Then I've got a flash file from National Geographic embedded in as well. I'm sure you're really happy that you watched that commercial. Look at those froggies flying. Man. Okay, so let's take a look at the source for this. I'm going to zoom in a little bit just to show you a couple things. Remember that cool O that started the text that was once upon a time? Well, there's the image file for the O, and I'm saying that the image file is going to float to the left, and that means that it's going to float to the left of any text or anything else that appears with it. And there's a lot of detail about this floating stuff that I'll get into later in the semester when we talk about CSS. All right. Here's an example of some audio, which shouldn't look too shocking. It looks just like your notes. The video should look just like your notes as well. So that's cool. Here's an example of video using YouTube. Now, in order for the YouTube video to work, you have to use something called an iframe instead of a video element tag, which is a little bit annoying. But anyway, there's an example of how to use a YouTube video. And notice how nice and clean it is. There's lots of examples on the internet of how to embed YouTube into your HTML. Don't get caught up in all this crazy syntax, because it is very simple to embed YouTube videos. And finally, this monstrosity here that runs on for 11 lines is how you embed Flash. And the reason why it's a monstrosity like that is because it's HTML compliant, and it should work on lots of different types of browsers. There's shorter, tighter versions of how you might want to embed Flash in your HTML, but the reality is that that stuff may not work on a lot of different browsers. So all of this stuff checks out with HTML5. I hope. Yep, it does. So life is good. Alright, so if you want to see examples of HTML for audio and video, check on the course web page. And under the media link. And that's all I have for this video lecture. Alright, take care. Bye.